So for number 13, we get more into the proofs here. It says to write a 2-column proof, but I'm actually just going to do a flowchart proof, which is what I've been doing this whole unit. It gives me a little given statement that angle GFH is congruent to angle GHF. So I'm going to kind of do my little congruent marks right here and right here. I know those angles are congruent. And then it says that I need to prove that angle EFG and GHF are supplementary. Okay, well, in order to do that, I'm going to first start, and this is how my classes do it. I'm going to go ahead and start by writing my givens. I just like to write that as my step 1 always. So I'm going to say that GFH is congruent to GHF. That's how I'm going to start this. And in red, I'm going to write the reason, and this is just because it was given to me. Just given. Okay, so my step 2, let's think about what we have to do for step 2. So for step 2, I'm going to go ahead and just look at my picture and kind of disregard what I put in step 1. I'm going to ignore the given for now. I'm going to say that I can see very clearly that angle EFG and angle GFH are a linear pair. So basically what I mean is from like right here all the way to there is 180 degrees. I can see that with my own eyes, that those two angles form a linear pair. They're adjacent and their non-sharing sides are opposite rays. So those two are a linear pair. That's what I'm going to say. I think that's going to help me out here. Angle EFG and angle GFH are a linear pair. And I wasn't really talking about the linear pair, I was just basically stating that it was a linear pair. So my reason here is just going to be definition of a linear pair. And then my step 3, let's move on here. Step 3, all right, my step 3, let's see what else I can do. Well, if I know that those two angles are a linear pair from step 2, I also know that they are supplementary, because that's just, that comes from that linear pair postulate. So I'm going to go ahead and write that out next. I know that EFG and GFH are supplementary. And I know that from my linear pair postulate. So if I want to say that two angles are supplementary if they're right next to each other, I first have to note that they are a linear pair. Then I can move on to my next step that says they're supplementary. And I'm going to go ahead and draw an arrow in between these because I knew that I created an if-then statement. I said that if EFG and GFH are a linear pair, then they're supplementary. So my fourth and final step here is to use my congruent supplements theorem, the converse of it. So basically I'm starting with the fact that EFG and GFH are a linear pair, and I know that EFG and GFH are supplementary. So I'm coming from right here, I marked that little green dot. I know that EFG and GFH are supplementary. Well, I know that GFH and GHF are actually congruent. I know that over there too. So the thing in common there, the angle in common is GFH. That's the same angle in both times. So what I can say is that if GFH is the same as GHF, I can replace it in my step 3 in that statement. So basically I can say that EFG and GHF are supplementary also. That's what I'm going to say for step 4. That's what it wanted me to say. I'm saying that EFG and GHF are supplementary. And that comes from the converse of my congruent supplements theorem. And I know it's the converse of that theorem because I'm starting with the fact that two angles are congruent, and I'm ending with the fact that they're supplementary. So if I was starting with the fact that they were supplementary and trying to get to the fact that they were congruent, that would just be the regular congruent supplements theorem. But I'm using the converse, so I'm coming from congruent and I'm moving to supplementary. And that's it.